For the past 5 years, our team of 12 volunteers has been imaging and digitizing weather documents with a focus on the needs of the International Surface Pressure Database, the ISPD. In that time, we have created over 50,000 high-quality images and rescued approximately 200,000 pressure readings. We are representative of many data rescue events in the ACRE community. In this presentation, we'll cover some of the lessons we have learned and also canvass opportunities we have as a community to add value to the efforts we are all engaged in. Creating the electronic record is a process that has a number of individual steps. A better understanding of the issues a team like ours faces as we execute the process should help to define the confidence level that you, the researcher, has in working with our data output. As a retired information systems analyst, I'm concerned we are losing two opportunities. First, we should be ensuring that researchers have the information required to form an opinion of the value of the data they're working with, which of course is their right. One way of addressing this is to include a data manifest with all data sets that are submitted to the ISPD. Second, the ACRE community is converting cubic meters of paper documents into millions of electronic images. It's tempting to see the images as simply a stepping stone to digitizing the data relevant to the ISPD. The images are then discarded or lost on a disk somewhere, potentially unavailable for further reference. However, that's a short-term view of the value of this resource. ACRE images have an enduring value for a number of reasons, and they should be part of a curatorial regime, that is, an image repository under ACRE sponsorship. If we put in some extra effort now, the value of our data and images to current and future researchers would be. Taking the first topic, issues associated with data capture, there are two concerns associated with the accuracy of data. The first is the problem of derived data. In this image, we have an exaggerated example of what can go wrong with data from a derived document. The newspaper typesetter quite obviously chose the wrong number in setting up the printing plate 126 years ago. But consider the chain that is involved in getting this column of readings into newsprint. The data was first handwritten by the observers, then transmitted by telegraphers, then copied by receiving telegraphers, then placed in a table and transcribed for delivery to a newspaper office even before the typesetter was able to make the mistake. This derived data source has a potential for transcription errors that doesn't exist in original records. The second threat to data accuracy is the potential for data entry errors, simply that the person entering the reading into a spreadsheet may make an error. We deal with data accuracy problems using a 5-stage checking regime. So taking the advice of a meteorologist, we were advised that in our part of the world, values of column inches of mercury below 28.6 or above 30.8 should be investigated. Equally, abnormal intraday variances of greater than 0.88 should also be investigated either side. We then rank the data to check highs and lows to see that they weren't transcribed incorrectly. And we do other such things as looking for abnormal row and column alignments. So if you have barometric entries for Sunday when you don't expect to have them, you then go back to the original documents to see that the figures were transcribed correctly. We also have other difficulties in getting accurate data because handwriting is difficult to interpret. Despite the belief that before the advent of keyboards, handwriting was an art, believe me, it could be as bad as the worst handwriting you see today. Additionally, ink blots were a hazard of pens that preceded the ballpoint pen. In some cases, we're lifting data off synoptic charts. These present problems of interpretation. For instance, picking off this data point, marked as 95, requires determining where it fits between two isobaric lines. Also required is determining what station is involved. In this case, a single letter N is used to indicate Cape Northumberland. Sometimes the station letter is obscured altogether. This is actually a very clear synoptic chart with well-marked isobaric lines, station letters, and pressure readings. More likely is faded lettering, which may have been clear 130 years ago, but is far from clear now. Luckily, we have a meticulous and well-practiced volunteer who actually enjoys the challenges of lifting data from synoptic charts. Metadata is important as we submit the pressure readings to the International Surface Pressure Database. Important data about the station that took the reading is the correct station name, its number, its latitude, longitude, height, and the height of the instrument. If available, there is other metadata that is worth capturing. Getting this metadata is not always easy. For instance, the Australian Weather Bureau does publish metadata on the web about its current weather stations, but these are only the name and the latitude readings. Luckily, we have access to the Bureau's internal intranet that has a complete file of stations, giving us access to historical stations that no longer operate, including all the relevant metadata needed, such as the latitude and the longitude, the station height, and the bar height. We do have a problem, however, in this case because there are two station numbers, and which one do we use for the ISPD, the WMO number or the local bureau number? When working with data from other weather stations, the important metadata is simply unobtainable. To be fair, the ISPD does have a reference file, but is not fully comprehensive for our region. New stations sometimes have to be referenced when we have observations done by early meteorologists. For instance, the earliest readings in Adelaide were done in 1841 by George Wyatt, a doctor. We managed to obtain an old map of Adelaide and determined that Wyatt lived in a home surrounded by large gardens. The problem is that that block in the city now is occupied by a parking garage. To get the required metadata, we used altitude.nu based on Google Maps. One could query the station height given that 170 years of building has occurred in the intervening period, but it's the best information we can get. By the way, you might note that latitude and longitude readings are supposedly accurate to 14 decimal places, which stretch the imagination. An audit trail would be useful so that researchers now and in the future can determine the provenance of the data they're using. To do a background check, of course. Researchers should be able to trace backwards to the source of the data that has found its way into their work. And there's reasons why they may want to do this. They may want to determine whether the readings were done by a trained observer. In this case, we do have a foundation record kept by the colony of South Australia. Presumably, this would make it a reliable document. Researchers may also, though, want to cite the original document to trace what look like potential errors, for instance, verifying data against similar readings. In this case, if only the 9 a.m., noon, and 9 p.m. readings had been digitized, then further granularity could be had by referring to the 3 p.m. and the 6 p.m. readings. There's also a need to check whether the source of the data is derived or not. Derived data is error-prone, especially from newsprint, as we mentioned earlier, but derived data comes in many forms. This derived data comes from NOAA's image repository. Volunteer teams are currently digitizing some of these documents for the ISPD. Though it is an official meteorological record, it is still several stages removed from the source documents and may therefore have errors built into it. In the 19th century, a human chain and not a self-checking electronic chain would have been involved in collecting and printing these tables. To be able to trace the provenance of a data item, we need a data manifest. By adding a metadata field to each digitized data item, researchers can then be linked to the relevant manifest. A data manifest is typically used by archivists and information systems professionals. In our case, each time a data set is submitted to the ISPD, it should be accompanied by a manifest, which at a minimum lays out a description of the data, including the dates covered, the geographical area of the observations, how the observational metadata was determined, for instance, the latitude, longitude, and station height, and also to inform how the original images can be accessed for reference. A data manifest should also identify the source documents of the images, who did the data capture, relevant workflow issues that impinge on the data, copyright, and contact details of the data rescue group. This is a data manifest that we created to accompany the Todd images when we sent them to the Australian National Archives. It's far too complex for our purposes in ACRE, but adds a good starting point we can work from. ACRE could specify a shorter, more flexible data manifest to accompany any data set that is submitted for inclusion in the ISPD. This proposal that we have on the screen at the moment includes the following headings. An ISPD series number, which is a unique index field that is attached to every data point in the data set. This links a data point with its manifest and allows researchers to access potentially important information about the data they're working with. My attempt here is rather clumsy and overly long. Usually the series number should include the collection ID, in other words the work group that created it, and a code that uniquely identifies this manifest, which could be generated either by the ISPD or by the work group itself. There should also be accumulation dates that show the period covered by the data set. The agency recording identifies who holds the original documents. The description field would be a flexible field but can be used to record the full range of data actually contained in the original document beyond just the pressure points that were digitized by ACRE for ISPD. Relevant station details could be included and how they were determined. It could be included along with instrument details if available and reasons for believing if the data is normalized or not. Also included could be any useful insights by the dataset owner, observed flaws in the original documents, and so on. The workflow field is also flexible but could be used to describe the data assurance regime used to ensure the data integrity and to point out possible flaws in the process of capturing the data. As mentioned earlier, issues of handwriting, interpretation, skill of the digitizer, and so forth. In this case, the digitizer Derek Reed noted a preference on the part of the original observers for even-numbered Beaufort scale readings. I note here that the issue of identifying derived data has been discussed with the ISPD for coding into the report code metadata field, so it doesn't necessarily have to belong in the data manifest. Copyright. In the case of copyright, the use of the Creative Commons licensing should be strongly encouraged because it simplifies the declaration of copyright conditions. The fact that we are dealing with old documents often means that copyright is clear and should be declared as so. A final comment to be made is that consideration should be given to using metadata fields that meet the global IPTC standards. The use of IPTC fields may give our data a higher profile on the web. Though a manifest goes some way in providing assurance to research, it is much more useful if there is also access to the original images of the data. This can be achieved by the establishment of a foundational images repository under the auspices of ACRE and the ISPD. For instance, in my case, I cannot get interest from my own meteorological service to host our 50,000 plus images of historical weather. There's a number of reasons involved, but I suspect the main one is that we are a volunteer group engaged in a project that's not of the Bureau's making. Be that as it may, many of us are creating images, and even if we had the support of our NMSs to host them, researchers would benefit from a centralized international repository. Weather research isn't bound by national boundaries, and we shouldn't have to go on a hunt through various government archives if we have the opportunity to capture all the images now in one repository. The image repository would give the ACRE community definitive evidence for the audit and provenance trails. Being able to cite the original document is an important step for research in determining the value of the data they're working with. However, an image repository would also preserve the resource, which potentially has value well beyond the limitations of the creation of data for the ISPD. The images could give researchers access to other data. In this image of a ship's log, we've digitized the pressure and attached temperature readings, but there are also dry-wet temperatures, wind direction, wind force, and general remarks about the weather. In our case, the Todd journals we're working with contain much more than the pressure data we've digitized. So for instance, they contain a synoptic chart, they contain max-min temperatures, they contain river level data, they contain wind and rain data, and indeed they even have written synopses of the weather. Ideally, for the foundational image repository, we would ask a host to meet 3 criteria. The images should be discoverable, meaning that normal search engines would find the images on the web. It's not just specialist researchers who will want access. We want community history groups and social historians and the like to be able to find our images. Even for science researchers, though, our data and images are of interest to more than just meteorologists. Researchers working in other areas of environmental science would find the data and information valuable. Thus, it's important that the repository and its contents are organized for web discoverability. The data manifest may have a role in doing this. The images should also be accessible. Ideally, this means that word searches can be done to find data specific to a time period and or a geographical position. Again, this is where the data manifest might be useful. The images should also be viewable and even downloaded without special plugins, Mr. Noah, and they should also have very few copyright restrictions impeding research and publication. The image host organization should also have a commitment to future-proofing the collection. This means a rigorous backup regime with frequent integrity checks. The images should also be proofed against inevitable changes in technology. Finally, it's important that our host organization has a long-term commitment to curating the collection. Ideally, their core competency would be archiving. As a community of interest, we're creating a resource that deserves to have maximum value for science and community research. Establishing a comprehensive curatorial regime for our work would be a major contribution in that enhancement. We have the chance now of getting it right. Thank you.